Hi, I'm Pete, and welcome to Just a Few Acres Farm. Seems like we're farming clocks and tractors these days. That's the nature of winter work. This is part 2 of my church clock repair series, and in this video, I'm going to rebush this clock and show you step-by-step how that's done. We'll fix the pallet, which is scored up by the escape gear or wheel, and we'll replace the pins in the lantern pinion, at least one of them, that are worn. So let's get to work. The first job is to rebush all of the pivot holes that I identified were loose in this clock, and you need some simple tools to do that. The first decision you need to make is what system you're going to go with for bushing. There are two competing ones, KWM and Verge, and I happen to use the Verge system. The difference between the two systems is the size of the bushings and the sort of standard table of sizes that you use. I don't know, it was kind of a random decision with me. I went with Verge. The second tool you need is a Reamer, which goes with your system, and there are these little reamers that go in the clock plate. I'll show you how they're used. In a holder, I do them by hand. I don't use a machine to do them. It's pretty simple to ream through brass, and you need a set of fine files to true up the hole and find the center of the holes. And then you need brooches. Brooches are, I believe these are 5-sided, and a brooch is used to slowly enlarge the hole till you get the precise fit you need for the pivot that goes in the hole. So with that simple explanation of the tools, I'll walk you through how to bush a pivot hole. As you'll remember, I made arrows that point to the way that each pivot hole is worn on this plate, and the back plate too. So the first step to replacing one, we'll take this off and carefully look at the way that the hole is egged. You can clearly see that this one was very loose and it egged way out this way. Now the nature of the way that this reamer works is that it centers itself in an oval hole because of the way it's just two-sided and it spins around. So what I want to do is recenter this egged out hole. In other words, the center line of this hole is right about through here and it's egged out this way. I want to make that egg go both ways an equal distance by working with a small file on the opposite side of the pivot hole. So I spent some time working away with the file, and now I've got that egg both ways. Wore on that side, I've filed it out to that side, checked it on both sides of the plate to make sure that the center line of the hole has been returned to where it was before with an equal amount of egg on both sides. The next step before I go any further with putting a bushing in is to identify what size bushing I need. And I use a little set of digital calipers, and I do everything in millimeters for clocks. So this is the pivot that fits in that hole on the end of this wheel, and I just take a reading of the diameter of that pivot, and it reads at 1.48 or 1.47 or 1.49 millimeters, a little under 1.5 millimeters. And I have a bunch of sets of these Verge bushings, and the first thing I look at is what the inside bore diameter of the bushing is, and I need one that's around 1.5, and that one has a 3.5 millimeter outside diameter, so I dig that one out. Let's see, 1.5 is right there. There's that little teeny bushing, and I test fit it onto the pivot. It's snug. Fits on the very end, but not down further, so I know that that's the one for me. These bushings that I'm using are available in either brass or bronze, and I happen to use the bronze versions. The bronze are a little bit harder, which to me translates for a longer wearing life for the bushing, so I'm putting bronze bushings into a brass plate. So the next step, if I'm using a 1.5 millimeter bore, this bushing here, it's got a 3.5 millimeter outside diameter. So I need to find the correct reamer size to create the hole for the bushing. And I don't know if you can read that, but that's a 3.47 bore diameter reamer. So it's 3/1000 less than the bushing, which will ensure a tight fit for the bushing in the plate once I ream out the hole. And then I just go to work with the reamer going into the hole, and the reamer automatically centers itself. It's just the nature of the way that the reamer's shaped into the new egg hole that I've made. And to get it started, you need to just be patient, and you try and keep the reamer square to the plate in both directions so you get a straight hole. Uh-oh, look at that. That hole had a bushing in it, and the whole bushing came out. Luckily, that bushing is smaller than my reamer, so I can continue to ream that hole out. And I know that I've got a good center because the whole bushing came out, and the bushing's round. So we'll just continue to ream that out. Just take it slow. Now the reamer has a flat part in the end. It tapers, and then there's a flat part. As soon as you get that flat part in the hole, you want to stop, because if you keep spinning the reamer, then you're going to loosen up the hole, and the bushing's going to be too loose of a fit. So there's my reamed hole. Next, I take the hole and I put it on this little anvil here, and then I get my bushing. And the bushing has an oil well in one side. You want that to go toward the outside of the plate. That's where the oil sits in. The oil's the pivot. And I just take a small punch and tap the bushing into place. You want the back side of the bushing to be flush with the plate, and I'm not quite there yet. So if at first you don't succeed, use a bigger hammer. It's my motto in life. Now once I've got this bushing flush with the inside face, then I have to set it. And to set it, I use a center punch, and that's going to expand the bushing a little bit so it seats into that bore tightly. The next step is I have to fit the pivot to the bushing. So if we put the bushing in the back side here, it doesn't quite fit. It's very close, but it doesn't quite fit. So that's where the broach comes into play. And I just use the broach to slowly, ever so slightly, enlarge the hole. So you just spin the broach and it works away at the hole as it spins. And I try to work from both sides because the broach is tapered as it goes up. So if you work from both sides, you're more likely to get a hole with the same diameter from end to end. We just broach a little bit, test fit. It's starting to go in there a little further. Try the fit again. This is where experience kind of comes into play. I've read that you want about a 15-degree play on these arbors, so 15-degree slope from square. I depend more on the amount of looseness I see here and whether I get a lot of side-to-side wiggle. It's good. That's a good fit. Oh, I forgot to show you one step. This is called a smoothing broach, and it's round as opposed to the cutting broaches, which have sharp sides on them. After you're done cutting, you run the smoothing broach in, and what it does is it takes out any irregularities in the bore, and it also serves to densify the brass or the bronze a little bit so that it wears longer. After I put new bushings in each wheel, I put it back together and check it. And I just did this one here, which is the third wheel, and it's not smooth. In fact, I can turn it from the low end, but not from the spring end. And it's important to assemble and disassemble. I'll do this dozens of times before I'm done with this clock. To change a bushing, check it, and then take it apart. Obviously, that third wheel bushing is a little tight. See, it's tight. It should spin freely. So one of the pivot holes needs to be loosened up a little bit. Just broach this one out a little bit more. By the time I learn how to put this clock together quickly, I'll be done with it. That's what we should have. That kind of spin right there. It's not rattly, and it spins freely. And now when I put it back together, I've got nice movement. It's silky smooth. Just the way I like it. Now I have all the new bushings in, and I've got good movement. I'm happy with it. It's normal you should have a little wiggle in these pivots. You need a certain amount of looseness for things to run easily and smoothly. While you're going through this, you want to check axle shake or axle end play. And each of these shafts here should move back and forth a little bit between the plates end to end. They need that freedom of movement to stay loose. So if one's tight, you need to move the bushing that you put in or out, or do some other kind of fix. Runs very nice now. The next thing I want to fix are the spokes or the trundles in this lantern pinion. These are badly worn, so I need to pull the spokes out and put new wires in to replace the spokes. There's a few specialized tools and supplies I need to replace the lantern trundles. The first is a pin vise. I have a set of pin vices. They're just made to hold very small things like this teeny tiny drill bit, and a set, or I have a couple sets actually, of teeny tiny drill bits. This one runs from 1 millimeter up to 2 millimeters, and then I have some that are even smaller than that. And I need new stock to replace the trundles with, and this comes in batches of mixed sizes. And I haven't mentioned this yet, but my clock repair supplies I get from Time Savers. I think they're in California. There's 2 national companies that are online that are great for getting supplies for old clock. Merritt's in Pennsylvania and Time Savers in California. So everything I need, bushings, these things, tools, it all comes from there. I hope you can see this clearly. I'm going to show how these trundles get replaced. If you turn the pinion to the top here, this is the hole, these are the holes that the trundles were inserted into, and then a knurler ran over them. Usually they're knurled a lot better than these, and these actually look, because of the age of this clock, like possibly somebody just staked these in with a flat stake. They made an imprint that deformed the brass a little bit to close up the hole just a touch to hold the trundle in place. So in order to take one out, I just take the appropriately sized drill, and the way I figured the appropriately sized drill is I took my calipers and I measured the diameter of one of the trundle wires, and it's about 1.2 millimeters, a little less. And then I picked a drill size that's just a touch bigger than that, and then I just go round and round and drill that hole out like so. Just remove that knurling, that's all I do, or that staking that they use to secure the trundle in the hole. And then after I've worked on it a little bit, I take a pair of side cutters and use them to grab on that trundle and push it up through the hole. You can see it's coming up now. Takes a little bit to get them out. Once I've taken the trundles all out, I got them all laying down here on the towel. You got these teeny tiny trundles that I pulled out. I can get a more accurate reading with the calipers on the diameter of them. 1.12, and of course in the old days, the tolerances were a lot greater than they are now. 1.15. Let's see if this one will fit here. I've got these in all different sizes. 1.15. I'd say that's good enough. Now I have to cut new ones. This is a delicate operation. I got to get the length right, so I use an old one as a template here. Then just use the side cutters to cut it to length. You got to hold on to both ends of it or they'll go flying. Ask me how I know. There we have a new trundle. And there are 7 trundles to be replaced, so I need to cut 7 of these. Or maybe 10 of them, because 3 of them are bound to go flying. I'm just kidding. Well, that one went flying. Boy, isn't clock repair exciting. Look at all the action that happens working on an old clock. Luckily, this was easy to find. It flew into the sink. Here's a new trundle, and usually what I have to do is drill these holes out a little bit to get it to fit in without too much. Well, I don't know, maybe that one will go in there. It does. We got to make sure we seat it down into the bottom hole here. And I can use another piece of that trundle wire to just push it in and get it seated. Ow, that hurts. Ouch. One trundle in. We're trundling along. Now I can put the rest of these trundles in. Maybe. Well, get in there. You know you want to go in. Well, let's try you instead. You told me you wanted to go in there, so I'm going to put you in. It's good that if they're a very snug fit, because it means I don't have to do anything to hold them in place. And here's the final result. I only got one war wound from the job. All new trundles on this escape wheel. Next I have to repair the pallets on the Verge here. And you can see how I got divots in them from where the escapement, or the escape wheel, ran on them. And to take those out, I just sand them. I've got a piece of steel plate here with sandpaper on top of it. And I just draw it across, trying to stay flat. And then I work down in grit on the papers to get a nice shiny finish. The angle of the pallets is very important to engage the escape wheel correctly, so I'm going to be very careful doing this to make sure I don't change the angle on them. Once I get the divot out with the coarse sandpaper, I'll switch to polishing with the finer ones. Sounds kind of like a donkey. Hee-haw, hee-haw, hee-haw. I know. This other one's kind of tricky because it's on the inside of the pallet, so I have to hang the steel plate over the edge of the counter so I can sand at the inside of it. And this is what it looks like after coarse sanding. Here I've got the divot out of there, the divot out of there. Now I can go on to the fine polishing papers. And here's what the pallets look like all polished. I can get them really smooth. Again, it's all about friction. You know, I got to editing this video and realized if I put all the work in one video, it'd be like 40 or 45 minutes. So I'm going to end this video here. I've done all the repairs to the parts of the clock. In the next video, I'll put the clock together. We'll test run it, fix the issues with the case and the face, and we'll have it back to the church in no time. Thanks for joining me, and I'll see you next time.